Great job, Gunnar. And thanks to you and Spectrum Enterprise, a MEF 3.0 certified provider, for jumpstarting our discussion today with an informative look at service provider challenges and opportunities in transforming the customer experience.
If you'd like to pay your bill, press 1. If you need technical assistance, press 2. If you'd like to speak to a customer service agent, press 3.
No.
For English, press 1. Para español, presione el número 2.
Thanks for calling. This is Jeff. How can I help you?
Oh, thank you. Thank you. It's John. I'd like to add a service.
Absolutely. Happy to help you with that. Hold, please.
What? Oh, come on. What? Shifting gears to the Analyst Corner, we continue with market insights and research data from Cliff Grossner, Principal Single Shot Consulting, and Dalia Adib, Director Consulting and Practice Lead, Edge Computing, STL Partners. Cliff is a 25-year plus industry veteran covering data center, IT, and networking, currently an independent industry veteran. In addition, Cliff is active within OCP Futures Technology Initiative and a member of the program committee for the OCP Futures Symposium, as well as chairing the High Performance and Hardware Acceleration track. Now, Dalia is an experienced strategy consultant currently working at STL Partners, a boutique research and consulting firm focused on the telecoms and technology industry. They explore how the sector can derive real value from innovative technology such as AI, 5G, and edge compute. And notably, Dalia was shortlisted for Edge Woman of the Year in 2019. Cliff, Dalia, I welcome you and turn it over to you.
Hi, Cliff. Really looking forward to our session on Edge.
Yes, Dalia, great to be talking with you again, and I'm looking forward to a vibrant discussion. I wanted to share with you and hear what you think about the fact that I still think there's confusion out there in the marketplace about what is edge, and even unfortunately, I still see some what I call edge washing going on.
Yeah, I think that's fair enough. It's still a gray area, and I don't think any analyst would claim to have a completely succinct definition of edge. The reality is that a lot of things that used to not be called edge computing are now falling under the edge umbrella. So an example of that are regional data centers. So this idea of moving fairly large compute power to a more regional location. We're seeing a lot of investment happening in Europe, in tier 2 cities there, in new countries, new cities in Asia, and also in the US as well. A lot of tier 2 city data centers popping up. So that's a form of edge. There's a lot going on in the telecom space, and we tend to refer to it as network edge computing. You might have a different term. And that's really the idea of the telco operators and others putting edge compute in their network facilities. And then you have kind of on-prem enterprise edge, and that's really about putting compute capacity at the enterprise site, which could be a factory floor in a manufacturing setting. It could be a retail store. It could be a shopping mall, shopping center, lots of different places. And then the last level, which is the most edgy of them all, is really putting more edge compute in the device itself. And I've seen examples of that starting to happen in the video camera space, where you have this idea of smart cameras, so the camera itself not only being able to collect data, but actually start to do some of that processing and act as a compute platform. But I don't know, what do you think, Cliff? Does that resonate with you? Is there anything you think slightly differently?
It does, actually. And, to add a little bit to what you said, for those of us that like to quantify things, there's a couple of different measurement systems out there that I think are also worth noting. One is the use of round trip time from user to compute platform of 20 milliseconds or less as one way to say, okay, this is an edge location or it's not. I've seen others have a grid where they use latency versus available bandwidth to decide if something might be edge or not. And then, of course, there's also the open source definition put forward by the Linux Foundation that really defines only two types of edges, the cloud provider edge and the user edge. And they further subdivide the user edge based upon device type. And I think, all of those edge definitions are valid based upon what you're trying to achieve. And I think it's also important to keep in mind that edge is really a reversal, in some sense, of the data center consolidation trend, which was kicked off by the desire to use enhanced AI and ML techniques, which need high performance compute over large data sets, and that really can't totally be achieved in the cloud, right, in a centralized data center. Now, I've also seen some of the work that you've done around use cases, and I think it's quite exciting. And so maybe you could help me try to understand a bit some of the use cases you're seeing before I share a few of the ones that I've come across in my research.
Yeah, sure. I think there's a lot of interest and exploration happening in the industrial space. So I'm not sure how familiar you are with the term Industry 4.0, industrial IoT. There's been this general trend in sectors like mining, oil and gas, manufacturing, even warehousing to change how the industrial processes are kind of designed and architected and what infrastructure they use. And there's this term around IT-OT convergence, which is really about bringing IT processes, operating models, innovation models, and infrastructure to the OT, to the operational technology floor. And what that means is that it, rather than having some core OT processes being conducted in a bespoke or proprietary piece of manufacturing equipment, the idea is that you could offload some of that to a nearby edge compute. It's still, that's still early days. The idea of taking a robotic piece of machinery's control system and processing that outside of the core machine is probably a while away. I would say, at least 5 years out from us getting past proof of concept stage, because, you're having to design something that works in all scenarios, that can comply with health and safety as well, that can provide a mission critical application and performance. But there are some early ones. So some interesting ones I've seen are a lot about computer vision, using video analytics. So using video sensors now to augment general IoT sensors. And that's really interesting for kind of quality assurance. So during, say, the manufacturing process, you want to be checking, is the product that we are producing, does it look right? Does each component look right? Is the machine that's conducting that manufacturing process working in the right way? And being able to detect that in real time is hugely beneficial, because something goes wrong and the manufacturer starts producing defective products. That's millions of dollars wasted at the end of the day. Not just the costs that are wasted, but you might have customer complaints down the line. There's a whole host of things that really make the business case. So seen a lot in the industrial space. And that's interesting. And, back to our original question around defining the edge, we did a research study recently, speaking to a few enterprises in that sector about which edge would they use for those types of use cases. And it really varies. So you have some customers, some enterprises using existing data center infrastructure, which do exist in large manufacturing sites. Some are using these kind of micro edges, like a little containerized box, which is running of some virtualized infrastructure and the applications. And then you have, kind of things in between. So it's really exciting, but it's definitely not straightforward. So I'd say that's an interesting use case domain that we've been looking at.
Oh, that's great. And much of that really lines up with my research as well, especially around the manufacturing area. One of the things that I might add to that is the gaming area, and bringing in the AR, VR, which a lot of gaming platform providers, I think, are looking at and investing in quite heavily. Yeah. And we've seen some success there so far, although that's more of a traditional IT environment, admittedly, but still needing to move, depending upon your definition of edge, need to move that closer to the end user. And then we've also heard a little bit about immersive experiences in stadia and things like that, changing the experience of being in the stadia once we're allowed to be there again, hopefully in the near future. And then, of course, it wouldn't be complete, I think, to have a discussion about edge computing if we didn't mention mobile devices connected over 5G as another important emerging use case. And also, I think a lot of people think very quickly about the public network, but also there's a lot of private networks being rolled out, potentially 5G type. So I think those are some of the other ones that I would add on top of those that you were mentioning.
Yeah, I think that's a fair point, because 5G is not only going to be a catalyst for some of these edge use cases, which will use 5G as the access technology. It's happening with private 5G networks, which is allowing these especially these industrial sectors, to innovate and access some of these edge use cases and do things differently to what they do today. I think the venues one you gave is a great example of some of the events. But I think with 5G that's interesting is it's also a use case for edge, right? Because of the virtualization that's happening, and the 5G core, for example, is it's software based in nature, which is different to previous generations. It will use edge compute infrastructure. RAN, the access network, is also moving towards that model of virtualization as well, containerization. And so with the telecoms industry, it's both a consumer of edge and it's also potentially a provider of edge as well.
So shifting gears a little bit, I was wondering what you were thinking about the top business drivers. So we've talked about, the end user experience. What's the business reason that you're seeing for some of these changes?
Yeah, I think it depends a lot on the use case. So if we take the first few that I was describing around the industrial space and this idea of using videos as a sensor and the IoT, they're the driver for using edge computing and processing data more locally is a few things. One is being able to reduce the amount of data that has to transport over a very wide area network, and moving data to a central server or cloud can be very costly, particularly when it's high bandwidth, real time data. So that's a real benefit that comes with edge. If you can process it on site, then you can only take back what's really needed to be stored for the long term to a central server or a cloud. The other thing, in those scenarios that comes up a lot is data privacy. And so to some degree, there's been a barrier to adoption of cloud-based IoT technologies in those sectors because they are often designed to run in a public cloud or in a remote cloud. And many enterprises in sectors like oil and gas and manufacturing have quite strict sort of guidelines and policy about where they store operational data, and they need it very much in their remit and often on site as well, and complete and physically quite separate from any other network or any other partner, customer, competitor, whatever it may be. So data privacy is often a reason, and by putting edge compute, you can keep that data within your premises. So that's for those types of use cases. Then you talked a little bit about gaming, right, and augmented reality, virtual reality. Well, to be able to offset what tends to run on the VR headsets, all that processing that happens to generate a really rich image. If you want to render that on an edge, you need a very, sort of sub 10 millisecond latency between the headset and the edge, so that the person who's wearing the VR headset doesn't feel dizzy, that they're able to look at something in it and kind of have a frame of reference and see something that's real and kind of high definition. So that's more of a latency play, I would say, for edge, to be able to do that. Similar thing with gaming. It's really about reducing the latency between gamers, and reducing the latency that comes with cloud gaming as well, which is a kind of a trend and a business model, I suppose, that's coming through in the gaming industry. So I would say of those. I'm not sure if you've seen some other business drivers, though. I've probably forgotten a few as well.
So we've definitely seen all of those in spades. And in fact, one company that I'm on the advisory board for, who started doing telematics maybe 10 years ago, and today their systems are all centralized. The first thing they said when I said to them, you need to start to look at this edge computing technology was, wow, we could save more than 30% of our bandwidth costs by moving some of the compute closer to the edge pretty quickly. So that supports what you were saying there. And the other ones that I've heard about around public safety monitoring, analyzing the video and behavior of people in real time to see if someone's doing something suspicious, are some of the ones. And the last one that we shouldn't forget is, especially for the telecom providers, is to provide new revenue streams for them through new applications.
Yeah. The other,
and I think those are the
some of the drivers.
Yeah,
sorry, just thought of another. So I think the other thing is flexibility, because in the past, infrastructure has been quite static and rigid. So you brought up the venues and the events example, I think, before. We've seen some proof of concept happening with I guess quite mobile events. So an example would be, these racing tournaments or even golf tournaments that happen once a year in a certain location. And often the event organizer has to kind of carry their infrastructure with them, no matter where the sport is occurring, where the event is happening. And there's various amounts of, there's various applications, I guess, and systems that use that compute infrastructure. I think, what we've had is what would be great is if they had access to an elastic edge compute, which is likely to run maybe in the network edge or maybe in an urban location, a nearby sort of edge data center location, and allow them to basically have that ability to move their workloads no matter what country they're in, no matter when the sport is running, and only pay for what they use. So it's more of a commercial reason. It's that they don't want to have to pay for the infrastructure that's fixed and have to move that and pay for the transport cost, as they move their event. And also, there's a lot of just maintenance and logistics that go around having to do it that way. So I think that's quite an interesting use case with a slightly different business driver as well.
In fact, Wimbledon tennis tournament is a great example of that.
Yeah, they have a huge. This might stretch my knowledge, but I think they have a huge, essentially computer underneath the stadium, if I'm not mistaken. So, and that must be hugely costly to maintain. But maybe it's time to offload that to a nearby edge compute.
So I think one of the other topics that was really important that we said we wanted to talk about, and is the idea of the cloud versus edge versus IT ecosystem.
Yeah, and I know this is something that you've when we had the discussion beforehand, you've kind of almost highlighted there are these three ecosystems coming together. So it'd be great if you talked a little bit more about that around where those ecosystems are starting from and how they're sort of converging together, I guess.
Yeah, and I think what I would like to do is share with people a bit of what we've seen happen in the last 5 years around distributed computing technology, which has totally changed the game with the adoption of software containers and Kubernetes. And what's really happened is now we can build software that's constructed using hundreds of components that are lightweight and can be developed very quickly. And effectively, people want to write once, run everywhere. Well, now that we have the capacity to deliver a use case that with coordinated workload components deployed where they need to be from a centralized data center to the edge, creating an IT ecosystem that is breaking down the cloud versus edge silos, we now have to think about an IT ecosystem and stop thinking about, is it cloud, is it edge? It's really all of that in a coordinated fashion. And I know that the hyperscalers have been doing a lot to get engaged in the game because of that. And I think you had mentioned earlier that you had been doing some reading on that.
Yeah, so the hyperscalers are huge, right? And they are supporting different industries with different offerings, and they're moving into the edge compute space. But I agree, what's happening in telecom specifically is new, and it's part of that whole trend to change the value chain, right, which we talked about. Each of the hyperscalers is taking a very different approach. You have Microsoft, who's made 2 huge acquisitions in the telecom space through MEF-CECP and Affirmed, and are providing more of a full stack offering because they now have the network functions, the applications to take to market as well. But they also have they've got variety in their offering. They've got the pure infrastructure play. They have a In some cases, more of a sort of a software play. They're looking at private networks. They're looking at the public network edge. And, AWS, Google, IBM, they're all using their heritage in hyperscale compute, and now kind of altering it so it's ready for the networks. I think the reality is that, we've spoken to a few telecoms operators. It will take time to change how telcos run their network and the infrastructure choices they make. Just like we saw with virtualization, we've been talking about it for 10 years plus now, and it took some time to kick in, and 5G now is accelerating that. So I think also this idea of changing the value chain, changing how networks are built will take time, but there's definitely been some interest. And we recently did a survey to kind of find out from the telecoms operators how much of their infrastructure was going to come from hyperscalers across different domains. Some of them being, to run their edge compute applications and platforms. Some of the domains will be more networking, so to run their core network infrastructure, RAN network infrastructure, private networks. And the area that came out on top actually for hyperscaler support, one was edge compute at the network edge sites. So that's more to support the applications. But some of the other areas which were a little bit higher than we thought at this stage of the market maturity was also distributed core network functions. And they felt that hyperscalers to complement their edge platforms, they could provide infrastructure to run and host their distributed core network functions. So that we are bound to see more of that. But I think that's really changing. It's definitely changed the relationships that telcos have with hyperscalers, but it's hugely complex. And I think there are still some open questions about where do we work with them, where are we competing with them, just like there are with their other partners as well.
It's interesting what you're saying, because I've been telling anyone that would listen to me for the last several years, since the public cloud, or the competition between on the public cloud has resolved itself between the cloud providers and the communication providers, that a new ecosystem had to evolve, that it couldn't continue the same way. And that, we have the cloud providers with a stable of customers running applications over the top, and we have the communication providers that had a similar stable of customers where they own the last mile. And when you look at edge computing as it's emerging, that's a hugely important piece of real estate, however you add it up. And so it's really with edge computing that the communication providers have a chance to, if you like it, get back in the game, as far as I'm concerned, in the market, and leverage their sought after edge computing real estate. And as long as they, as you said, are careful about the challenges, that they, leverage innovations from the cloud providers rather than try to duplicate everything, especially around AI and ML and automation, that I think there is a new ecosystem springing up where there's enough cooperation to make it viable. And that's what we're going to see. And in fact, it begs the question, right? What is the role of telecom operators moving forward? And, if we look forward 3 or 4 years, is Google different than, I don't know, pick your telecom provider?
And I think it depends a lot on which telecoms operator. Each has a slightly different strategy. Some prefer to focus on their connectivity business. Others are looking to, move up the value chain, looking to consolidate a kind of compute. I think one of my colleagues, David Moss, talks about a net compute offering where they, bring the two together. And yeah, each approach is slightly different, and that will also determine how they work with the hyperscalers as well. Because I think in some cases they see them as competition, and in some cases, they're more than happy to work with them because they're a great customer or they're a great partner for them to roll out these state connectivity services.
It'll be great to circle back with you in a year from now and see what happens with the Microsoft AT&T deal and how that really worked out.
Yeah. Yeah, no, definitely. And I think, the other thing with telecoms that we've heard in terms of we've interviewed a few enterprises, and we ask sometimes the question, what's the role of the telecoms operator? Do you prefer to work with a cloud provider, telco, others? One thing that does come up is the idea that, first of all, the telecoms operators are a local partner. Another thing that comes up is this idea of trust, and that they have secure networks, this idea of security. I think something that we haven't talked about probably in the analyst community yet as much is how you secure the edge. What does that mean? How different is that from securing cloud connectivity today? So I don't know if you've got any specific thoughts on that point around security.
I do actually. I usually have thoughts on many things, and
I can count on you, Cliff.
Many of the vendors that I talked with actually talked to me about physical security, and not for a data center building, but actually for publicly deployed facilities. Like, I do believe there's a project that's in the public domain around 3,000 street boxes going in Barcelona, and there's a lot of work being done to add GPS locators into the server, so if the server gets moved, or mercury switches if it gets tilted, or anything like that, that server becomes inoperable and the data gets wiped. So really to protect the physical devices itself. But then we also need to look at, if we look at the IT side of things, the entire hardware software stack. And I start right at the bottom with a hardware root of trust for the components, so that all the components in the device are identified and know each other, and you can tell that they have not been tampered with. And then we need that root of trust to move up to the firmware level, where any firmware upgrades and any firmware needs to check out, and we need to know that it's not been tampered with. And likewise to the OS level, that same root of trust has to go all the way up to the OS level. Then, of course, we get to network security, which we've all talked about time and time again, and that needs to be embedded in the communication components of the device.
Yep.
And then when we look at the application stack, we also need to rely on having proper identity management and key management, so that anybody accessing any of the applications that ride on top of all of that is identified properly and has the right access policies applied. Those are my first thoughts on security.
Yeah, no, I think that makes sense. I haven't looked at security in as much detail. I think one area that's interesting is some of the innovation happening around securing multi-tenanted data centers, which are going to be much smaller. So, with large kind of colo data centers in the past, you've had these kind of cages, physical cages to separate different tenants, whether it's, a content provider versus a corporate enterprise. When it's much smaller, it's a much smaller facility, you don't have as much space to do that physical security. So you really have to be quite dynamic. And I think there's some startups which are doing some really interesting work, thinking about how things that used to, that are quite standardized in the data center industry, what they look like now with an edge data center. How do you provide that same level of security to all your tenants in an edge compute location? But I totally agree with what you were saying around, needing to secure things all the way up the stack. I've started to see a lot around this idea of zero trust. So really putting that zero trust kind of guideline and mechanisms, not like you say, not just at the hardware level, but the software level as well. But that's an area I should do some more reading on. So thanks, Cliff, for that nudge. But as always, it's been so good to speak to you. Been a really good discussion. Hopefully, I guess we need to schedule our next one in a year's time to recap what's happening in the telecom space and see where things are going.
I look forward to that.